All right, thank you everybody for coming to our Gate 6 presentation. We are Team 4.1, Sorting System and Tank.
For our problem statement, we partnered with Purdue Polytech High School and Anderson Hauser to make an interactive project with engineering concepts. Our project is to design a small-scale manufacturing system that has an interactive display, industrial robots, a conveyor system, and problem solving all integrated into it. This is our requirement matrix. Some key things on this are our 3 different sensors. We have a barcode, a height sensor, and a color sensor that is all integrated into this smart mini factory system. Another key thing is the teaching program completion, which we are creating documentation to give to the teachers and students so they are able to understand everything that we are providing them.
Moving on to our scope of work, we have refined the previous team's programming to make it a little more neat and readable for the high school students. We've also refined PLC wiring also to make it more neat. The physical build optimization, we have improved builds such as the tank lid, as well as the table. We have put in chutes and bins for our containers. We have tested for accuracy and precision, and we have compiled and edited documentation to fit our project.
So we are team 4.1, and this is our sorter project for PPI. So what we're sorting, we have these lovely canisters here of different heights and 3 different colors. And we will be sorting using our color sensor, height sensor, and we have a barcode here, but it doesn't sort by that. It just reads the barcode that will be on top of those lids. It's all controlled by our lovely PLC here, looking very beautiful. And all of this is wired up correctly. It doesn't need to be messed with. Now you can control these sorting methods here on our HMI. We are going to start with our color sorting. So we'll start our conveyor belt to start running again. There we go. We'll start with a red one here. So it's going to pass by our color sensor. Our 2 flippers are going to start to engage. And it's going to take that red canister and it's going to put it into this bin right here. Very, very slowly. Now, right now it just falls out the bottom. But we have these little latches here with strings. They're going to be able to release these in a, fairly uniform manner. So that's our system. We can sort by height. We can sort by color. So let's take a blue one, but now we're sorting by height. And we'll stop it right there. So that is the sorting project. It's still got a few kinks to work out, and this is definitely not the finished version, but this is its functionality. And we look forward to delivering it to you sometime in April. We'll get back to you on that one.
As shown in the video previously, some of the major things we did was we rewired all of the PLC and the cabinet so that it is as bare minimum as possible and as constraints that the students don't have to mess with it and should not mess with it. The PLC programming has been optimized for a new setup and that it doesn't need to run tedious tasks, so it's more efficient. And every line has been commented so that the students can know what each rung is doing and why it's there. The collection bins were added to make it easier for the bins to be collected and then sorted out throughout the process. The flappers redesigned to shift the center of mass away from the center of the flapper to being more localized on the motor to reduce the motor strain. Right now we are messing with the motors timing so that they are consistent and ensure the maximum longevity. And this will slow down our consistency testing. And we created documentation on how to run each of these scenarios and what any potential error may arise and how to maintain them for the coming years that this sorting system will be a part of the PPI program.
Okay, so this is the second part of our project, the much simpler part. We have our water tank here. Primary purpose is to just fill it with water, have a whole bunch of sensors that the students can play around with. So everything's controlled through our Liquiline box and our DC power supplies. Most of everything here was donated by our very lovely partners at Hauser. Underneath here, we can get to the guts of the thing. We've got 3 valves that control intake, cycling, and outtake. Intake, cycling, outtake. We have a separate video on how to work that. All of our electrical equipment here, it's all very secure. It's been tested for leaks. Lovely little bubbler there. Coming around here, we have the most interesting part. We have our Pico mags. They are flow rate and temperature sensors. The bottom one is for intake, and the top one is for our output and cycling. And then coming up here, we have a radar level sensor, an analog level sensor, and right over here is our pH sensor. So really, you just fill it up with water. There's an app that you can look at all of the data and recalibrate the sensors as needed. I know there are tutorials online for that. And please check out our video on it actually working and how to manage those valves down there. Thank you.
So the water tank, what we've done, we brought it up to full functionality. When we got it, it was hooked up to the PLC. That was how it was getting its power. We've made it independent by adding those DC power supply modules on the side. We've routed all of the wires through the right conduits into the Liquiline sensor. We refurbished the lid to be a bit stronger and just look a little bit nicer as well as being safer. We added the hose attachment to the input to make it compatible for most intake hoses. We tested it for leaks, as said in the video. We filled it up and drained it 15 times and didn't have a single leak. We tested our sensors for accuracy, and we created documentation on how to function, how to correctly operate the system.
So the team has worked together and provided several technical documents relating to the sorting and the tank filling trainers. These technical documents consist of detailed descriptions and operating procedures for both systems, as well as basic navigation, calibration, and connection of the Hauser devices used on the tank to the Hauser Smart Blue app. The team has also recorded and provided videos on the purpose, functions, and operating procedures for the trainers as additional documentation for individuals who prefer visual learning. Technical documentation on safety hazards present in these systems, as well as emergency protocols and procedures, have also been written to ensure the safety and well-being of individuals operating each system. Finally, all documentation will be provided to the client in separate binders based on the system it correlates to. Next slide, please. All documentation throughout this project has been completed using Microsoft Office products like Word and PowerPoint. The teams communicated with each other, all team members communicated with each other and the clients through Zoom calls when it came to project updates. For the gate reports, the team worked together to ensure that each gate report has been updated prior to submission. And this includes updating the test reports, the bill of materials, and the project schedule, which is shown in the next few slides.
So on this slide, we're going to talk about our test plan. Our sorter, we wanted to shoot for a 90% accuracy sorting by testing it manually and verifying that each of the canisters fell into the right bin. We have tested it somewhat, but since we are still tweaking our flappers at the moment, we haven't been able to 100% test it yet. The tank, however, has been fully tested. As we've said, we have no leaks, and we have verified the accuracy of both of our sensors within acceptable error ranges.
So now I can take us through some of our budget. So some of the things that we talked about in the past that we had already purchased were a few 16 and 18 gauge wires that we needed, each in a few different colors. And then there was also the 4 aluminum L brackets that we purchased to repair the top of the tank. And then some of the newer things we just purchased were we needed to purchase a black and white Olympic wire from Allied Electronics, as well as the Yusong Shine motors. And then we also purchased Velcro strips and filament for the 3D printer off of Amazon. And then as well as some black oxide screws from McMaster-Carr. And by the end of this, our total budget ended up coming to be around $283. And next slide, please.
I'll now be taking you guys through the design plan Gantt charts. This is a living, breathing document that was updated consistently throughout the entire year. It outlines the planning, execution, testing, and all our due dates for our project reports throughout the entire semester. In here, you'll see that we have the planning for the sorting document, which we were able to complete last semester. And then when you continue on, we have the executing for a sorting system. And this is including the physical build for the electrical and the build for the code and integration. The executing for the tank was completed on 3/3/21. And this included the physical build for the tank lid. Next one, please. And all the wiring. Then we also have sections for the testing for the physical. So this includes the sorting system and the tank. And then our extra part of our project was creating the lesson plans. Next slide, please. Our planning for it was finished on the 5th of February, and then we continued to the executing lesson plans, which we were able to complete this past week. Next one, please. These lesson plans were able to be completed for both the tank and the sorting system. A lot of these documents were given to us by the previous team, as well as a compilation of both systems. And then after that, you'll see all the due dates for the gate reports. Please continue. Please continue, next slide. Up until the ones this week, which is the Gate 6 report, as well as the tech demo on the 29th. Next one, please. Right here is a very good overview for a better visual on how our project was broken up throughout the entire year. As you can see, most up to date is today on the 26th. All that's waited to be completed is the drop off and as well as the tech demo and Gate 6 report. Thank you.
These are our references, and now we'll be available to take questions.